Madam, we are live now. Please.
Thank you, sir. Good morning, all. I, Dr. Swapnaja Patwardhan, Assistant Professor, MESS IMCC, welcome all the participants and today's guest speaker for FDP in Artificial Intelligence for Education, hosted by IMCC in association with ATAL and AICTE. Before starting, a brief introduction about IMCC. MESS Institute of Management and Career Courses is having 37 years of standing in the field of IT and management, affiliated to Savitribai Phule Pune University SPPU Pune and recognized by AICTE New Delhi. We have MCA and MBA programs, and our MCA program is accredited by a National Board of Accreditation. In addition, IMCC is recognized PhD Research Center under the Faculty of Commerce and Management in SPPU. We also have BBA, BBACA, and BPAIB. The total student strength on campus is around 1,000. Pleasure to introduce a distinguished speaker of this session. Professor Kamal Bijalani leads several ICT-based educational technology and pedagogy projects such as AMPLE, AView, and others. AMPLE is the LMS with advanced pedagogies like outcome-based education, personalized learning, reusable competencies, blended course creation. Professor Kamal holds patents for classroom exam uh, proctoring and assessment devices. He is the designer of AView platforms developed by Amrita for interactive online classes installed at 12,000 institutions under Ministry of Education. Using a AView, lakhs of teachers and students have been trained. Earlier in USA, he was technical lead at AI startup companies from MIT and Stanford. Kamal Bijnani sir will be accompanied by his associates Soumya MD, Pradesh N, and Jayahari KR. Welcome to all of you. The global pandemic has taken a massive hit on all the sectors of economy. With disruptions everywhere, several concerned scholars, citizens, politicians, and bureaucrats supports the need for reimagining and reinventing the education system. Hence comes in the smart classroom system. Smart classroom is a typical environment for smart learning, and it is the high-end form of digital classroom. Use of technology in education is one of those methods that will help improve the quality of education. Moving a classroom online is not an easy task, especially for those who are new to teaching remotely for an extended period of time. Suddenly, words like distance learning and virtual classroom are on everyone's lips. Sir and his associates are going to throw a light on smart classroom environment, virtual classroom, pedagogy, learning, and assessment. I request Kamal Bijlani sir to proceed with his talk. Over to you, sir. Thank you.
Good morning. I hope my audio and video is clear, ma'am.
Yes, sir.
Okay. Warm welcome to all of you, and thank you very much, ma'am, for that wonderful introduction. Really appreciate it. So, today our associates are, Pradesh, Madhuri, and Jehari will be joining a bit later. And together, we will talk about a little bit about the online learning environment as well as the smart classroom setup. And another area that, Pradesh will be covering, for example, today will be, how to do attendance and proctoring during exams. Now, this proctoring during exams, which is live exams in the smart classroom, can also be extended to, proctoring when we are doing exams at home now to some extent. So we will be talking on a variety of areas today. To give you an idea of the, what role AI has been playing, even like I was telling you, I've been associated with AI since the 90s. And at that time, we had a system like, for example, called eMySim, which was done at Stanford. So the idea there was, even at that time, given the symptoms of a patient, the system was able to, in over 95% of the cases, give the diagnosis. So everything was structured like as a rule-based system in a so-called expert system, and all the findings of the patient, all the symptoms and their tests, every test that they have undergone was also part of the input, so to say. And then the system would very much based on a set of rules, like an expert system with like a decision tree. It would go down the tree and then give you, the answer as to what is the problem. Same kind of AI system can be used for diagnosing something, like a decision tree or a if-then rule. However, when we have neural networks, and also when we have the machine learning algorithms, they can be used for classifying things and recommending things. So in these cases, again, at a high level, we have to be aware that we have to train these algorithms. For training, we will need a fair amount of data or use cases. So I need hundreds or thousands of students' marks, and in which area they have done how well, to train my system. And then that training system can be used for recommending and classification. So these are some of the ways in which, we are bringing in AI. The other is, automation. Like when I have a robot, by combining various technologies from different disciplines, also you can create, an AI-like system. So if I use, the image recognition of a robot in a robot, and let's say the robot goes around and checks in the classroom. Imagine that I have a robot and it walks around the classroom, or let's say, and make sure that nobody's cheating, for example. So that is very much, possible, because the paths and the aisles can be defined, and, the robot, need not have just one camera, one set of eyes. It can have multiple, and it can rotate also. So all such things come from our imagination. So imagination and creativity is very important in research, in innovation, in inventing new things. We first have to be able to imagine something, no matter how crazy it may seem. At some point, initially, for to do something, we have to allow our child, the child in us, to imagine something crazy. And it doesn't matter, whether it is possible or not possible. There is a part of us that can dream and imagine. So as a researcher, that part of us should always be alive and playful and curious and down to earth. So that part of us is probably the most important part, because once you imagine, create, or dream something, then the rest of the mind, the rest of the army can follow, and we can try to make that dream come into reality. So that process of imagining, dreaming is probably the most critical part of any research endeavor, and the same holds in education, AI, and other places. that the people that I have seen and met in, in the world over, in the research areas, they're very much like, and they, part of them is very much like a child. So that childlike innocence, curiosity, ability to dream, I would say is one of the fundamental things that we should all bring to the table, so that we can then proceed to build that dream, so I just wanted to briefly mention this, because this is what, we have found to be very important in our experience. So moving on to real things, I will start by giving you a very brief overview of how we are using Bloom's taxonomy as a teacher. Okay, so for that, I will share my screen, and I may turn off my video. One second. Pradesh, can you see my screen?
Yes, sir.
Okay, great. Thank you.
Yes.
So here, I have our, platform that we started mentioning yesterday also, called Ample. And, I'm logged in as a teacher who's Vidya Bala Subramaniam, and she's a computer science teacher at Amrita. And she's teaching these courses, and she's the mentor. And you can see she's teaching program reasoning, and all these sections are there, A, B, C, D, and so on. Now, for that particular class, they will have the LMS part, which means, what does the student see? So this is what the student sees on their side. They see that unit, and they see all the PDFs, and there's a quiz in between called proposition logic, for example. So like that, the teacher keeps creating all the course materials and shares it with the students. Plus, the teacher also, has a live. They use Microsoft Teams, but it doesn't really matter. Zoom or Teams or Google, they're all similar. And then that is how this comes. So after the students take the quiz, then the reports come into play. So what is this report card of the student here? This report card is telling me that they have several graded tests, and many of them have taken 6 tests. And content view tells me that totally I have shared 24 pieces of content with them. And these, these are the numbers seen by each student. So I'm seeing per student report, and then I'm seeing their performance here, that, who has performed how well, and I can sort that. So I can see the students who, have scored overall higher or highest, and I'm seeing their content also. So as I'm trying to understand my students, I want to know now more detail about them. So what do? When I created my course, remember, like we said yesterday, the AI or the intelligence or whatever analytics, business intelligence we are doing, it's very important to set up the right models first. So what is the model in this case? The model is that I have a course, and for that course, I will have some course outcomes. So I will define my course outcomes there, and here you can see the course outcomes. I have defined 4 course outcomes. Now, for each of these course outcomes, in these are computer science courses, so these are program verification course. So there are 4 course outcomes defined here. And then for each course outcome, I will define a learning objective. And each learning objective has a set of questions. So this hierarchy is defined. Once this hierarchy is defined, then I have a deep pedagogy model of my curriculum, so to say, of what I am going to teach. And then when the performance of the student comes in, that gets plugged into this model. So let me show you how that works. So we have the course outcomes, we have the learning outcomes, and then, here you're seeing the learning objectives. Unit 1, you're seeing the yellow code and the yellow description. These are the learning objectives. And you're seeing which course outcome this learning objective is mapped to. So these are the course outcomes. Each learning objective is mapped to. And you can see the number of content that is there, and you can see the number of questions and assessments that have been conducted there. So this is the model. And as my questions and assessments go up, these numbers will keep on increasing. So what is this? Once I have done this modeling, then based on this model, I can go and look at my report. So when I see my report now, which I was just seeing, the students' report, I'm not only seeing the marks of each student, I have other types of reports. What is the other type of report? It is called the LOCO report, which is based on my model.
Hello, sir.
Provided here for the students will be shown here, and this is available to you over here. So here, these on the left are my 4 learning objectives. So you can see these learning objectives and you can see their names, and you can see for each one I have in my course right now I have around 64 students or so, and for each learning objective I can see that these 57 students are green. What is these colors are shown in the legend below, and this you can change as per your policy. This is greater than 60, 40 to 60, and less than 40. This is how I have made the 3 ranges at the bottom. So for each learning objective, see here in the first learning objective, I am pretty satisfied. Why? Because 57 have done reasonably well, 7 are doing medium, and two have issues. Fine. Now, if I look at the last learning objective, they're also similar results. Most of them have done extremely well. A few are intermediate, and one. In the third, this learning objective, the case is slightly different. 36 have done well, and 21 have done okay, and 9 have done not so well. So the number of not so well has increased. Whereas in this learning objective 2, the situation is slightly different. As you can see, in all 3 are almost equivalent. That means this analysis tells me that this learning objective was not even understood by 20 people. So because they have done poorly, these 20 people. And these 19 people have done intermediate and 25 have done well. So what does that tell me as a teacher? That tells me as a teacher that this learning objective, most people were not able to grasp for whatever reason. Maybe because I didn't explain it properly. Maybe because, the students didn't have the proper background. Maybe the exam was difficult. Maybe the questions were not clear. It could be multiple reasons could be attributed to the root cause of this issue. So how do we create an AI-like environment for us so that when we see something like this, firstly, most systems don't give you this analysis. Today, when you get your report card and you give your grades out, you are giving out of, periodical 1, periodical 2, and final exam. 3 main exams and some continuous assessments. But we don't get analysis per learning objective, which is what we are getting here. So this clearly tells me that this topic, prove the correctness of sequential programs, this particular topic, there is a fair amount of difficulty on the side of the student. So my job as a teacher or as a department head is to dive deeper into this issue, find out what is going on. And as I said, the next step that I would do typically would be that I would try to find out what questions were given for this test, where was this LO used, and so on. What was the difficulty type? So some teachers here at Amrita, what we are doing is we are following what we are calling the Bloom's taxonomy level. So let me show you the Bloom's taxonomy level report. So the Bloom's taxonomy, as you would all know, we have 6 categories: remember, understand, apply, analyze, create, and evaluate. So in this particular teacher, Dr. Vidya Balasubramanian, all her questions are created in these 3 categories. You can see remember, understand, and apply. Those 3 types of questions have been used. In fact, I can see that under remember, there are 7 questions for 14 marks. Under understand, there are 10 questions for 16 marks. And under apply, there are 37 questions for 90 marks. That means most, as you can see, out of the total questions, 37 plus 10, 47 plus 7, 54 questions, the majority of the questions are from apply, more than 50%, in fact, in this case. So as a teacher, this also makes it clear to the HOD, for example, that the teacher is giving more application level questions, not just questions where I just remember something, by heart something, and put it out. This gives you an overall idea of the pattern of what is going on. And by seeing, what is going on in apply, I can sort the students according to the application. And oftentimes, what I have found along with many of the teachers is that many of the students, who are not doing well in the exams here, will also usually not do well in the next one. Okay, in the application type of questions. So if I sort this in a reverse way, I see that some of the students here, are getting 20 to 40 or 50% marks. So what we can do now, firstly, we have done a lot of analysis here, then what would be the next step? Once we have done this analysis, now, by the way, this is just one section. As you see on the top, this is BTech Computer Science Section A, okay, which is about 60 students that we are seeing, 66 as the top. Now, I have 4 such sections. So, I have 250, 260 students. I can bring all 260 students in the same, group, and then say, who out of these 260 students, who are the 10, 20, 30 who have not done well in the application? I can even talk to them. I can even give them a gentle, message saying that, look, if you are having any difficulties, please talk to your mentor or your counselor or come and have a meeting with us. We will try and help you before it gets too late. So you have to imagine that what all data we can get of the students, how we can get it at different difficulty levels, how we can get that data at different Bloom's taxonomy levels, and then what can we infer from that? At what point do we give a warning to the student? At what point do we tell the parents? Those are difficult things. And then, every institution will have its own policies for that. So we have now come up with a system where we just tell everyone how they are performing for each learning objective. And not only for each learning objective. So the learning objective tells you the topic wise, in which topics are you doing well, which topics you're not doing well, because that topic which you may not be doing well now, these are the topics, right? If you're not doing well in a certain topic now, we also map this particular topic, which was also going to be in your final exam. If this is a topic, a key topic, like let's say differential equations, and you are going to do, more advanced courses which require differential equations, then we can warn you, look, later when you do the advanced courses, if you don't understand this now, you will be in trouble later. That kind of a recommendation, a warning system we can create for the students, and the teachers can also be aware of this. So what I'm trying to give you some insight that we need to build systems where the modeling is very important initially. How do we model the system? So here I'm showing you that one way to model it is by learning objectives or by topics, and also having relations between learning objectives of different courses. That is one broad modeling that we have done. We have a course, we have course outcomes, we have learning objectives have questions, and that model we have. The second area that I showed you here was Bloom's taxonomy, right? And the Bloom's taxonomy report tells me, now many teachers also have questions at the analyzed level, that also I can show you, but you get the idea, that application is much more important. For a job-oriented person, it is very important that they learn application type of questions and they do well in those. So if the students are not doing well in the application type of questions, then there is reason to be concerned about that and to make sure that they raise their standard. So extra counseling or whatever can be given to these type of students. Now remember, this analysis is cutting across topics. This is not topic-wise analysis. This is overall analysis of the type of questions that are being given out. So I just wanted to create awareness of this, so that there's one more report here called Continuous Evaluation Report. And this report, tells me all the quizzes. So, in this COVID time, the way we have been teaching, we have multiple quizzes, and very few exams. So all the quizzes, 6 or 7 quizzes are listed here, for example. So I can go to the right side and you can see quiz 4, 5, 3, all of the quizzes you can see. And, I can sort the marks according to some quiz, or let's say I go and sort it according to quiz 4, for example. So on the left side, you see their total performance also, and the breakup per quiz. So this is another way of analyzing how things are going forward. Because in a particular quiz, like quiz 3, you can see everybody's marks are relatively lower out of 20. Whereas quiz 1, everybody has high marks. And sometimes we do that purposely. In the first quiz or 2, we keep it fairly easy actually, because we want to motivate everyone to do well. So by doing well once, we hope to at least get their interest and their motivation. And then gradually some of the quizzes can get much harder. So my intent here today was to show you how to analyze, model, the modeling and the analysis of any area. And this is the area that all of us are most concerned with. How do we grade our students? How do our students learn? Remember yesterday, Madhuri gave you a demonstration of personalized learning. That is also part of this. For the personalized learning, basically the students, will get a report like this, but that will be their personal report. That means for each of the learning objectives, when the student does a personalized learning test, they will each get graded for each of the learning objectives. And that tells the student where they stand in each of these learning objectives. And the remedial measure for the student is given according to that performance. The remedial measure for the second report is different. The remedial measure for Bloom's is different. If a student, may be very good at, see this, student is getting 100 in remembering, but they're getting only 50% in understanding, and 60 or 50, 60% in application. This is a very good example. M. Bharati Babu, number 11, the serial number, is getting 100% in remember, 50% in understand, and 48% in application. So what do we need to do? We need to find out and train them how to, maybe they are not, how to go for the application type questions, and how to make sure they understand the concepts and practice the concepts so that they can do better in these application type of questions. So to summarize, I've given you 3 models here. The course outcome of a course. There are a few course outcomes and learning objectives and the performance based on that. Then we have the Bloom's taxonomy level. And we also have the difficulty levels that we saw yesterday. Those are another ways to model a course. So fundamentally, whenever we want to do AI, the modeling part is the most important part. Every phenomena, every area, wherever you want to bring in AI, you first have to have a detailed model of that. And you have to know what matters in your, what are the parameters that are important in your research, in your area, in that field. So modeling and knowing the key parameters is the most important part. Then the techniques of doing prediction or having the data or training the algorithm is also needed, but it is a combination of all of these that finally will give you a very good system overall. So I would like to pause here briefly, see if there are any questions, and then we will move on to Pradesh, who will be making the next presentation.
Participants, any question, please? Please raise your hand. Any question? You can type it in chat box also.
Okay, Pradesh, you can start sharing your screen. I'll stop sharing my screen.
Thank you, sir.
Yes. Thank you, Kamal, sir. Thank you very much.
So Pradesh will be talking about, the smart classroom and, how we can do attendance and how we can use image recognition, advanced image recognition techniques in the smart classroom for doing attendance as well as proctoring. Go ahead, please.
Yeah. Thank you, Kamal, sir. Hi, everyone. My name is Pradesh. I am working as a research associate in e-learning department in Amrita. So the last 2 years, we are working on a prototype in our university itself. It's mainly for an exam proctoring. we are working on both online and real time live class also. So here I'm going to show you some live class experience, what we have done and what is that prototype we have done, and we will explain to you little bit and what all research elements we added into that and what all the papers we published in that. Those are the things I am just going to explain to you. So here, yeah, I will go to the next slide. I hope you can see my screen, right? Yes. So mainly regarding this Amrita exam surveillance system, we have some video monitoring and some semi-automatic malpractice detections and some rule-based alerts and some predictive and post analysis. These all I will explain to you in the coming slides. And some research elements like face recognition and image recognition and something like head movement pattern matching, something we are doing. And the next slide, what is our current system is, right now we have a manual verification system here, and it requires a lot of intense monitoring and everything is required. And we are trying to automate that process little bit using some face tracking and recognition and movement recognition and all. So to give you an overall idea, I will just show you how our current exam room camera setup and exam room setup is there. Something like right now our exam halls are maintaining a common pattern. So based on that pattern only we have designed the system. The same common pattern is something like there will be 7 rows and there will be 10 columns. I mean, in each column, you can see 7 rows and 10 columns in this picture. No? So in each column, actually, there are one student is sitting. And these all are the predefined sitting position of that student. So in our system, we know, for example, in this position C5, who is sitting, and he is belong to which class and which exam he is conducting. Those all details we already have and we are putting as an input into the system. And this is the automatically generated seating arrangement for that student. So we know the students are going to sit in this particular format in this exam classroom, and we have arranged many cameras in this classroom, and we are using 2 static cameras and 1 cheap PTZ camera also. The purpose of the static camera is mainly recording that classroom, the entire classroom we are recording. And this PTZ camera is the purpose. It will go to each, it will zoom to each student and it will capture and it will record that person's actions. So the main purpose of this PTZ camera is it has some pan, tilt and zoom functionalities. So it can turn and it can zoom into each and every person. Even at the last person, it can zoom and capture its actions. So like so mainly we are using this PTZ, using this is an IP camera. We can there are libraries to control this camera. So we are controlling this camera using some programs automatically, and it will go to each student and it will capture that student's action, and it will keep on rotating in the classroom. So our basic idea is automatically this camera will zoom to each position and capture their record, and in between, if something is suspicious action is happening in that classroom, and there are many users of the system, there will be invigilators, teachers, code, anybody can see these cameras, and if they are seeing something suspicious in any of these positions, they can click on that position in their mobile app or in their web application, wherever they are using, wherever they are sitting, they can click on that particular position. Then the one interruption will send to this camera, and it will focus on that particular location, and it will capture, record their video for some time, and it will send a notification to all the invigilators, users, so they can also check, verify if something is happening there. So there will be many monitoring happening. That is code team will monitor, and the exam surveillance team will be monitoring, and the classroom teacher. And if some suspicious action is happening, everybody will get an alert into their system. into their mobile. Or so even a teacher who is sitting in the classroom, if they, even if he is missing something, he can get a message in his mobile, so he can watch that position properly, something like that we are giving. So to give you more clear idea about the overall system, I will just show you, we have created a small video about the system, so we can give you a small video, so we can show you a small video. So I am just stopping this share and I will play the video for you. Just a minute. Hope you can see my screen. There is some, this is the classroom surveillance system, and this is the classroom arrangements, and there will be 2-3 cameras. You can see that camera 1 and camera 2, and these all will be connected to the monitoring room, and they will see the monitoring. I mean, it will continuously moving and seeing, and if the invigilator sees some suspicious action or something, they can click on that particular location. Then the camera will be zoomed into that particular location, and automatically the notification will go to the invigilators or somebody, and they can come and check. So this is the overall idea of the system, how it is working. Now we will go back to the same presentation. Okay. Now we will go a little bit detail into the system, how all these functionalities are working. Now the next one is the overall classroom recording. So we are continuously recording the classroom. So even if the PTZ camera is missing some activities, because whenever it is zooming to particular location, it may miss some other activities. So to avoid that, we are continuously recording that using some static cameras, some cheap static cameras. We are overall recording, and this overall recording we are using later for the further analysis that I will tell you in the next steps. So, and there are many active monitoring and some intelligent alerts are there. And as I told you before, anybody can raise the alerts. I mean, even a scout team or a monitoring team or the teacher, anybody can send an alert for this particular position. Then that camera will focus on that particular position and capture that. And we can do more analysis, and simultaneously it will send the notification to everyone who all are watching that. And we have many rule-based alert also we have done, something like whenever the head movement is, we are capturing. Yeah, these are the research element. I just want to explain to you in detail a little bit more. Actually, we can configure something like how much degree we can. If the head movement is more than a particular degree, then we can give some alerts to the person. And if one person is looking to right and second person is, I mean, the nearby person is looking to left, something like that, if they are looking each other, that also we can track. So these are the research element we are trying to include into the system. So I will give you a little bit more details into that in the coming slides. These are some rules we can set in the system. Based on these rules, the system can do something automatically. That's what we are trying to achieve in this system. So there will be some, we have some algorithms, some AI-based algorithms, which will automatically, whenever, actually this system we have implemented in many classrooms. So, and we are feeding the data into that classroom also. I mean, in this morning exam, these are the students going to sit in that session. And in afternoon exam, these are the students going to sit in that classroom. So based on that input data, the system will generate their previous history and based on their previous exam marks. And so we are giving some extra input also from the teacher side and the invigilation side. So based on all these input parameter, the system will generate some risk parameter also for each location. Based on this risk parameter, they will focus, I mean, the camera will spend more time on those risk areas, something like that. If it is a low risk areas, then the camera won't spend much time on that area. So like that, we can define the risk areas also in a particular classroom. That will be changed. This we are calculating automatically. That will be based on the many input parameters defined by the teachers and the invigilation team. So other than that, we have some face movement analysis also, how where the students are looking and which angle they are looking, something like that. So we have done some analysis on this, and we have a patent also in this face angle detection. So we have, these are the some patent models we are using, how much, what is the degree it is turning to left and right. We will share you the patent details if you are interested in this kind of analysis. And there are many other malpractice detection also we are trying to automate little bit, like whether there are I told you before, something like one person is looking to right and another person is looking to left, and there is any continuity between their movements. Based on that also we are analyzing. So you can see here in this, whenever we are matching some face movements right and left, then we are considering this as a malpractice chance. I mean, the probability will be more very high in that area, so the camera can focus more on that area. So we are using some existing libraries and some our own algorithms also for identifying the pattern or the face location features, where all this, based on these features, we are identifying whether they are looking center or left, right. If there are nearby persons having these kind of movements, then the system is detecting that. Like that, we are trying to do that. So our main analysis, we have some basic analysis, some real-time analysis, some advanced analysis also there. Yeah, basic analysis mainly with the continuous monitoring, and there are some manual effort is also there. If even the system is missing something, if the person is, I mean, who are monitoring that system, they can raise the alerts, and based on that, the system will identify, and I mean, the people who are invigilating or the score team will get the notification. Those are the real-time analysis. And after that, based on this recorded videos, we are doing some advanced analysis also. Even if we are missing, the person or the system misses something, then after the exam, we are feeding this input videos into some other deep learning models, and we are checking. There are, I mean, that's a time consuming process. That is not a live thing. So the system is again checking on those videos, and if you have missed something in that, whether there is any movements, suspicious movements, something is there. So we have real-time analysis and the advanced post analysis also. There we are using a little bit more complicated deep learning models actually. And these are the applications which I showed you before. Each position A1, A2, A3, A4, something like each position is indicating one student sitting on that classroom. So if somebody is sending an alert to here, you can see in this one, the invigilator send an alert to B10. That means at that time, the camera will, when you click on that, we can see some minimum information also in this B10, what is happening. So these all are we are tracking. If something suspicious is happening, actually we are tracking that actions, and this trackings we are giving as input for the further analysis, whether there is something happened in that particular area. So they can click on this. When they are clicking that particular position and giving a if there is a chance for cheating or head movement or body movement or talking suspicious actions, anything, they can mention that and they can save it automatically. The camera will move to that position and record them, and automatically it will give it to the all the users the detail. And based on this, we have 2 patents also based on these systems, and we have 2 journals also we have wrote based on the how the head movement is should be matched and all. So these are the mainly the journals. The idea is mainly based on the how how much angle, how we can detect the angle of this face movement in an exact properly. So those were so we are using some yaw estimation angle from cylindrical models we are using to identify whether the how much degree the face is turning. So and we have some post analysis. That's what we are telling about these all are we are experimenting. We are generating some deep learning models and we are passing these videos into that model for the further analysis. And for that we have some more things we are with attendance marking. So here we have some extra features to automatically check whether the students are sitting in the right position and they are not and we are marking their attendance also automatically. The person attended the exam on right time, on right position, something like that. It's just a actually based on this we have identified, we have a proposal with the National Testing Agency, NTA also. We are working with them. So we have given a proposal to them actually to identify whether the right person is attending the NTA exams and all. So mainly for that we are using, for this face recognition, we are using some existing deep learning libraries for identifying using the same webcam conducted in the live class, both in the online class also we are experimenting this. In the live class, how it will happen is whenever we are capturing a person, we have their actual face also with us. So we are comparing that face and we are recognizing whether the same person is attending the exam or not. So we have, this is happening in the live class and live exam room. So the same functionality we have elaborated a little bit for the in the live classroom also. In the live classroom also, we can do the similar functionality to do automatic attendance, and there will be a camera in the classroom. So we have done some experiments like whenever the students enter into the classroom, they can face the camera as a single or as a group, they can face the camera and it will be marked into the system. We have a system called Ample, and this face recognition methods are integrated into that Ample. So automatically whenever they face the camera, their attendance will be marked and automatically that will be stored into the Ample system as their attendance. For this we are doing some face recognition techniques, some the models I will give you a little bit detail in the next step. So this is the overall workflow. In our Ample LMS, we have a list of all the students, and whenever the students come to the classroom and they are just facing the camera, this is just a prototype you are working, and it is using some face tracking, and for optimizing that it's using some face tracking and all, and some retrieving some basic facial features, and we are predicting who is this person, and based on that prediction we are marking their attendance and we are saving that back to the LMS and DB. So this is the overall idea of marking their attendance automatically. The same thing actually we are using, yeah, this is the UI of that our application, how we are marking how fast we are marking the attendance and all. The same thing we are using a mobile also. The teacher can record using a mobile. No need to face the camera. While any time whenever the teacher wants to record the attendance, they can open this application and they can capture just face the camera to the students and automatically all their attendance will be captured. So we have done some analysis and some prototypes and tested in the classrooms. Based on this analysis, we have written some papers also in this based on this analysis. So basically what it's doing here is there will be a learning management system, and this LMS, the Ample LMS will send the details to the mobile. I mean, these are the students in this particular classroom, and the teacher will select that particular classroom and they can open the camera. When the camera will capture the video of that face, and we will do some image tracking, face tracking. Based on the face tracking, we are sending the details to the servers and recognizing that persons, and we are storing the attendance. Even using a mobile app, the teachers can mark their attendance. And we have tested this in many scenarios, in the classroom scenarios, in the office scenarios, wherever we are. Also, we have tested that with Pradeep Kaul, who is the NTA National Testing Agency head. So he was also very much interested in this one. So we have submitted some proposal and we are working with him regarding this. And we have some, yeah, these are the some results when, as per our analysis, we have written some papers on this. So what is the interesting result? What you have noticed is using a mobile phone. So you can use a distance of maximum 3 to 3.5 meter is the good distance for capturing the attendance, and maximum you can capture at to 10 to 12 students. That is the maximum. Then if you are maintaining these thresholds, maximum 3 to 3.5 meter and maximum 12 students at a time, if you can do like this, then it will give the better performance, something like that. We have done some analysis and all, and of course it will depend on the mobile performance and all, mobile camera quality and all. So there are many analysis we have done based on this, and we have written a papers also. These are the FaceNet model we are using for face recognition and all. This is a Google model. They have given their model. They published their model, and we are using that model, and we are optimizing little bit in that, how to give the better performance. So these are their basic concept is something like a triplet identification. Based on that, if there are a positive, for example, mainly they are considering 3 images. If I want to while training the model, their logic is something like this. They will, to train the model, they will choose 3 images. One is they will choose the person who want to recognize, who system wants to recognize, and they will take a same person's another image, that is a positive image, and another person's image, that is a negative image, and it will train by itself multiple times to increase the distance between these two. Basically, the model will finally try to increase the distance between this anchor image and negative image, and try to decrease the distance between anchor image and the positive image. So to achieve this, it will train itself by multiple times. This is the basic idea of this FaceNet triplet. So we are also using the same model to improve this face recognition accuracy, and we have done some analysis on this, and we are doing some performance improvement also in this. So yeah, I will just show you some more images and I will conclude. So these are the type of malpractice we are also looking at, using some paper chits and sharing written answer sheet. They are sharing with them, talking. They are talking inside the classroom and talking outside. Those are the some sample images we can show you. These are the student. They are trying to use some chits, and also these are our test cases. We are trying to using some deep learning. We are trying to, these are the post analysis we are trying to achieve. Using this, whether we can identify these cases using a chit and paper in that, and whether the students are sharing their answer sheet and they are looking each other. So whether the system can identify automatically these things. That's what we are trying, and how they are interacting inside a classroom, whether they are talking or not. And they are talking to outside people also, whether we can detect these things. So these are the research element we are actually trying now to. We have some lot of data. We have experimented this in many classrooms, and we have a lot of data, and we are using this data. We are doing many post analysis. For that, we are using some deep learning models also. We are identifying this. We are trying to identify a pattern from these videos. So that's what we are working right now in this area. I think that's all for this exam surveillance and face recognition. Kamal sir, over to you.
Okay. Thank you, Pradesh. Thank you so much for giving an overview of using image recognition for attendance and proctoring. So I'd like to request Madhuri to share her screen. And, what we are going to show here is the idea of reusable competencies. So, Madhuri, do you have any, before we show this, can you just show the regular like CMS or whatever, where we have a course where we will be bringing in these competencies. So, see, all of us basically, when we are teaching, we have a course, right? That course has a table of content. That table of content, that sort of chapter 1, 2, 3, 4, 5, 6. Here she has many courses. All these courses are there. So she clicked edit course on one of these courses. And let's look at this internal of this course. I'll just stop, pause here. So suppose, imagine you are told to teach some new course, right? All of us are in the teaching industry. So we are asked to teach suddenly a new course. Now, we may not have ever taught that course before, or we may need to brush up our, concepts, get some learning materials, assignments, tests. And suppose, you're teaching a course and 50%, but the other 50%, we are not sure about. So what would we want to do? I, as a teacher, what I would like is, okay, there are some course materials sitting somewhere, and now I'm assuming a complete online world here for just to begin with, okay? But this same idea is true in the classroom also. If I have my course here, right, and I want to suddenly teach a couple of chapters that I'm not that familiar with, then I would like, and I know that my friend who's a teacher has taught this 1 year back, and I can go use their materials, right? Then I should be able to copy their 2 chapters, only the 2 chapters that I need, and paste them here. So that is the idea, reusability of content or curriculum or chapters, whichever way you want to call it. So Madhuri, if you go to that chapter and just click on that plus button, for example. Stop. So here, what do you see? You can see add chapter, add competency, and we have one more option now called import competency. Okay, so when I'm adding a chapter or a competency or whatever, means I have to create the learning materials here. But if I'm importing a competency, what it means is it already exists somewhere out there. And I am simply going to be able to import that competency or that chapter into my chapter, and it will be done. So this is the objective of this brief session, where we are going to show you that, look, all the learning materials, all the content, you need not create yourself, because that itself can be a big load also. We can share it. We can keep it in a common pool. We can call it a library of online materials. And that library can be reused by all of us to import materials and use them as needed. So here, normally, when you have a course, what we do is, she has a chapter there. Okay, just click outside. Now on the right side, in that chapter, do you have any chapter with some content in it? Can you just demonstrate and speak on some existing content, Madhuri?
Yeah, this is the chapter, and this is the subchapter. In this subchapter, I am defining some learning objective, and I'm adding the content here. Currently, I have some PDF I have added here. So it could be anything. We can add any content, like we support different varieties of content like video, MP3, YouTube content. I can show you the types. HTML, PDF, other files, SCORM, any content you can add it here. So you can create, you can add the content, you can make this like a package. So you can add your learning objective content, you can add enough number of questions, and you can export it to library so that anybody else can use the system and they need not sit and create all this. They can directly go ahead and use it. So these are like small modules, the reusable modules which are built so that course modeling can be done in a better way. So I can show you the library.
How do you add something to the library from here? Can you show that?
Yes.
Slowly. So this is exactly a very good example that Madhuri is about to show you, that any teacher, whatever is deemed as reusable can be put into the library. Go ahead, Madhuri.
Yes. So you can, to the library, you can give it as a link or you can give it as a copy. If you give it as link, it will be like, they cannot edit it. So it will be, anybody can use it. But if you give it as a copy, anybody can import and they can modify your content. Now I am showing you the competency library, how it looks like. So we have some competency name. This is competency, or we can call it some modules. The module name and the category and how many courses which are using this reusable content, and the learning objective count and the content count and the question count you can see in this table. So that you can see, like suppose if you see this reusable competency or the module is being used in 3 different courses. Currently it has around 4 learning objective and 4 questions. So I'll click any one of this and I can show you. Yes. Currently, you're seeing in this category, I have different varieties of competencies. I mean, small modules. Like I can say in the example, it could be this category could be maths. In that maths, you can have different small modules. The reusable module, you can build it here. So you can reuse it in different varieties of course. Like I would say, like maths, we need it for machine learning, data science. So like probability, you can create your like a competency or module, reusable module like a probability, and you can add your learning objective and related content here, and it's in the library. So, and any other teacher who is building the course or modeling the course, he can use this same this content, this reusable module, and they can just import it. They need not recreate once again. That's the whole approach of it.
Okay. So here, just click on that plus button. So, basically, what we were trying to say is that, click on that plus button and click on import competency. So when you do import competency, then you get, wait. So you get, your library. And from that library, you can do a search and add any existing module into your library. So this is the overall concept. What is the idea? See, over time, having small, again, as we have been saying all along, how well we can do AI always depends on our models and how we are keeping our pieces of information. So when a student is not doing well, let's say, in a particular area, what I want to tell them is, go study this topic some more. But in order to do that, I must have my content in the course. Not only should I have my content, I should have that same content for an advanced student and also for a beginning student. But at least let's assume I have one piece of content. If the student is not doing well in a concept, I should have a particular content in my library or in my course. Let's say, in the first year, this happens to us all the time, when 12th standard students join college in the first year, or if let's say they join an MBA program, they come from all kinds of different places and they are not equal and they need some bridge courses, right? Or it's not actually a course they need. So if let's say you have an MBA program, some students join in, and you want to start with an equal them so that they are equal. So for some of those students, we can have a pre-test a month before they come in. And then in that pre-test, we can find out which areas they are weak in. And then through personalized learning. And then we could take from our library or from our courses certain topics and recommend it to them, saying they should learn those topics before the semester starts. So the intent here is to show you many different things. And as I said, the application and automation of usage of AI will always depend upon your requirement or your imagination. So I think that sort of ends our presentation for today. If there are any questions, we can take them.
Hello, participants, you can raise your hand for any question. Any question, please? I guess no question is there, sir.
Yeah, there's a question by, so the question is level of questions, meaning whether it belongs to application, remembrance, is it defined by the faculty?
Faculty, yes.
Correct. So that's a very good question. Yes, that is correct. So the Pradesh, could you possibly show that how a question is given different Bloom's taxonomy level?
Yeah, yes, sir. Just a minute. I need to open that.
Yeah, take your time. I'll just explain it in the meantime.
Yes.
So basically, if I'm a teacher, then I create the question, and when I create the question, I get a drop down basically for difficulty level, and I can pick any one of the difficulty levels. And for the Bloom's taxonomy level, I get another drop down. So that drop down allows me to pick one of the 6 Bloom's taxonomy level. So this, you're correct. Through that drop down, I'm able to, for each question, I'm able to select what level it is. there is also what we have is a concept of a question bank. So there, you're able to see all your questions and see how many questions you have per learning objective, per course outcome, and how many questions you have for each of the Bloom's taxonomy. Pradesh, you have something to show, or is it taking time?
No, I just shared the screen.
Yeah, thank you.
In one level, yeah.
Yes, sir, it is visible.
I can open the questions, no?
Yeah.
And yeah, this is the section where we are creating the questions. And when you create the question, you can choose any type of question. For example, I'm choosing a short answer question here. And while creating the question itself, we can give some options like difficulty level and what is the learning objective and what is the Bloom taxonomy level for that question. These are while creating the question itself, we have these options.
Sir, I had one question.
Yes, go
Am I
ahead.
audible? Yeah.
Yes.
Actually, when we are talking about Bloom's taxonomy, every Bloom's taxonomy has some specific question verbs was associated with it. So is it possible to, or can it be possible to have, you type a question and by analyzing the content of the question or wording of the question, it automatically understand that whether it is a remembrance or whether it is a apply kind of thing. So can it be possible, or can we do this kind of thing also? So it includes again a kind of AI part over here.
Yeah, that's a brilliant idea, sir. Excellent. So that's a very good example now, because see, we have the model, and as you have correctly said, suppose it's a short question. Pradesh, go ahead and type a short question. Short answer, the question, and now say show an
Now,
application.
right.
Yeah. Now, when you write the question, what, sir, your good name?
Ravindra Vaidya.
Oh, okay, sir. Okay. Ravindra ji. So this, that's an excellent idea. So, in the question, remember the diagram that I had sent you, Pradesh?
Yes.
For the Bloom's taxonomy.
Okay. That image.
But
yes.
what sir is saying, just type a question here.
Yes.
Apply Newton's law to show whatever. He's apply APPLY.
Yeah. Correct.
So what sir is saying is that we from here itself we guess, we make a reasonable guess that this question is at the apply level. This is a direct application, but what sir is saying is for apply, there is a set of verbs, actually, maybe around 10 to 15 verbs.
Yeah, and that too, AICT has put up one document where they have put up all the verbs, question verbs they are talking about. And they say that, okay, for if this question verb is used for AIC, that particular Bloom's taxonomy.
Correct. That is already available online, sir. Yeah, that
right.
Standard thing is available. So yeah, AICT's thing, as well as there are other sources for that.
Right.
So that can be definitely done. That's an excellent idea for enhancing AI-like capabilities. Yes.
Right.
Because it combines natural language analysis, because obviously we have to parse this text. We have to understand the question, right? And then we have to map it to one of those verbs, and then we can make a automated guess for the Bloom's taxonomy.
And there is another thing that I would like to add here, that you have mentioned there is a difficulty level, right? So, for example, you have mentioned that difficulty level very high. and once the everything that means examination is over, and you found that the difficulty level is high, but 90% students are giving the correct answer for that. So does it
Correct.
mean that difficulty is really high? So that we need to understand that, and then it automatically changes that level by this is one parameter I'm talking about. I'm not saying that difficulty level is high and maximum people cannot give the answer, but this is one of the parameter where students can give the answer, and based on that particular answer, if the 90% students are giving the answer correct, so we need to think that whether really it is a difficulty level, high difficulty level. So, and we need to rethink on that. So you have to pop up all those questions where we have mentioned difficulty level is high and students are giving the correct answer. The number of students are more. Same thing for another way. If you are putting difficulty very low and very less number of students are giving the answer, correct answer. So that can be also automatically we can define the level of the difficulty in the particular question.
Yes, yes, that's also an excellent idea. And we briefly talked about it yesterday. But exactly, we have two papers on that also. Basically, you're exactly right. Once the difficulty levels are set to some value, then based on let's say the tests and the quizzes and the exams for one semester, that difficulty level can be normalized, right? Basically, let's say it has a value of high, like it's difficult, let's say it's 5, but if we find most students are able to answer it, we may bring it down to 3, for example. And same thing for the easy level question. So that value of the difficulty level can be automatically normalized based on the performance of students every semester. And that can be done through machine learning, and it becomes AI, and it becomes a self-learning system, self-adapting system.
Right. So that adaptive thing happen over here. And third thing that yesterday also, I don't know, I asked with if you have the text or a paragraph available from the book or something like that, we can create a system where it can uh, by their own create the questions. I'm not talking about a question bank and from that you have to select the question. I'm talking about it automatically create the question. That is also one of the problem that we can think of.
That is a much harder problem, but it can be, because there are chances of there being misinterpretations. But definitely that is one of the existing areas of research, where given some learning materials, the system automatically comes up with questions, and the general trend is that the simple type of questions are easier to form.
Right.
So if you have the topic name there, so obviously you can say what is that topic name, or explain the topic. Such type of questions are obviously easier.
Like for example, you can ask somebody that so and so is born in this particular year. So this sentence maybe automatically get created, who born on this year, or this so and so has born on which particular year. So this question can be get created. So that requires some kind of natural language processing and so on.
Exactly. The remember type of questions and the understand type of questions are more easily done in this kind of context, because the date, those are all remember type of questions, and also explain this phenomena or explain this concept. Whatever the parsing is done of that concept, we can always say explain this concept. So those two type of questions are definitely possible, and that is also very useful to automate that.
Right. Thank you, sir. Thank you very much, madam. You can continue.
Yes, sir. Thank you, sir. On behalf of MESS IMCC and all participants, we sincerely thank Kamal Bijalani sir and his associates Madhuri ma'am and Pradesh sir for accepting our invitation and delivering the talk. I thank all participants for their enthusiastic participation. Now we will conclude session and I request all participants to switch on your videos for photograph.